This animal has been doing exactly this for 110 million years. Before the dinosaurs were gone, before the continents finished moving, before most of what we recognize as modern life had any reason to exist, sea turtles were already crossing oceans, reading the magnetic field of the Earth like a compass, and dragging themselves up beaches to bury their eggs in the sand. 7 species are still alive today, each one different in size, diet, shell, and strategy. Let's start at the biggest. Leatherback sea turtle, Dermocheles coriacea. The leatherback is the largest sea turtle on Earth and one of the largest living reptiles. Adults typically reach 1.5 to 2 meters in length. The largest individual ever recorded measured just under 3 meters from beak tip to tail and weighed 916 kilograms. For reference, that's heavier than a racehorse. It is the only sea turtle that does not have a hard, bony shell. Every other sea turtle carries a rigid carapace made of fused, bony plates covered in horny scutes. The leatherback's back is covered instead with a thick, flexible layer of leathery skin, strengthened by thousands of tiny embedded bone fragments, like a mosaic of bone chips under rubber. 7 longitudinal ridges run from neck to tail along this surface, giving it a distinctive texture unlike anything else in the ocean. The coloring is deep black or dark gray, usually speckled with pale white or pink spots. The underside is pale. The flippers are enormous, the largest in proportion to body size of any sea turtle, which allows the leatherback to generate swimming speeds faster than any other non-avian reptile. The leatherback has the widest distribution of any reptile on Earth. It ranges from as far north as Alaska, Norway, and Iceland, to as far south as the Cape of Good Hope and New Zealand. It crosses entire ocean basins, Atlantic, Pacific, Indian, regularly completing round migrations of 10,000 miles or more between tropical nesting beaches and cold water feeding grounds. It thrives in water temperatures that would stop other sea turtles in their tracks. The leatherback has been documented active in water below 4 degrees Celsius. This is possible because it generates metabolic heat and uses a system of counter-current heat exchange in the blood vessels of its flippers to retain that heat near the core, a functional near equivalent to the kind of warm-bloodedness found in mammals, in a reptile. It is the only sea turtle capable of this. They eat jellyfish, almost exclusively. The leatherback's jaws are sharp, scissor-like, and delicate. They would be damaged by anything harder than a soft-bodied animal. This means the entire survival strategy of the world's largest sea turtle depends on eating an animal that is roughly 95% water. How a 900-kilogram animal sustains itself on jellyfish is genuinely puzzling. The answer lies in volume. A leatherback must eat enormous quantities, and it does so diving repeatedly, sometimes to depths beyond 1,000 meters. A 2024 record confirmed a leatherback dive deeper than a U.S. Navy submarine's operational depth. The same diet makes leatherbacks catastrophically vulnerable to plastic pollution. A plastic bag in the water looks exactly like a jellyfish to a leatherback. Ingesting plastic causes blockages, malnutrition, and death. This is one of the clearest examples of how ocean plastic affects large marine animals directly. Leatherbacks are solitary in the open ocean. The only predictable gathering point is the nesting beach, where females return every 2 to 5 years to lay eggs, typically on the same tropical beach where they themselves hatched. Within a single nesting season, a female may lay up to 9 clutches of eggs, each containing roughly 80 fertilized eggs, alongside a number of unfertilized ones. The hatchlings that make it to the water face extraordinary odds. Predators take the majority before they reach the surf. Those that make it face years of open ocean drift before maturing. Of all those that hatch, only a tiny fraction survive to adulthood. Leatherbacks can remain submerged for extraordinarily long periods. Their bodies excrete waste gases through the skin, partly bypassing the need to surface as frequently as other sea turtles. They also convert salt water to fresh water internally, ingesting seawater and excreting the salt through specialized glands near the eyes, which produces what looks like the turtle weeping. Conservation status is vulnerable globally. IUCN. But that classification hides significant regional variation. Pacific leatherback populations are critically endangered. Atlantic populations are more stable, with roughly 30,000 nesting females estimated worldwide. Green sea turtle, Chelonia mitis. The green sea turtle is the largest of the hard-shelled sea turtles and one of the most recognizable. Adults typically weigh between 130 and 200 kilograms, with the largest individuals approaching 300 kilograms. The shell runs 80 to 130 centimeters in length, heart-shaped and smooth. 5 central scutes flanked by 4 lateral scutes on each side. The name does not come from the shell color, which is typically olive brown to dark gray. It comes from the color of the fat and cartilage inside, a greenish hue produced by the animal's diet of seagrasses and algae. The name is literal. You can only see it when the turtle is on a dissection table. The head is proportionally small relative to the body. Eyes are large. The jaw is finely serrated along the cutting edge, designed for cropping vegetation rather than crushing prey. Green sea turtles inhabit tropical and subtropical coastal waters worldwide: the Caribbean, the Indo-Pacific, the Great Barrier Reef, the Hawaiian Islands, the coasts of East Africa, and beyond. They nest in over 80 countries and have been recorded in the waters of roughly 140. Within those ranges, they are creatures of shallow coasts, seagrass beds, coral reefs, and sheltered lagoons where their food grows. The green sea turtle is the only sea turtle that is fully herbivorous as an adult. Juveniles are omnivores. They eat worms, jellyfish, small crustaceans, and insects. But around the time they reach adulthood, the diet shifts almost entirely to seagrass and algae. The serrated jaw is the tool for this. They graze seagrass beds the way a lawnmower cuts a lawn, moving through patches of vegetation, cropping it at a consistent height. This has consequences that go well beyond the turtle's own survival. Seagrass beds that are grazed regularly by green turtles grow faster, stay healthier, and support far more marine life than ungrazed beds. The turtles stimulate regrowth. Remove the turtles, and seagrass beds become overgrown, stagnant, and gradually collapse. Green sea turtles are a keystone species in the most direct, functional sense. Green sea turtles navigate using the Earth's magnetic field. Each location on the planet has a unique combination of magnetic field inclination and intensity. Sea turtles are sensitive to both, and research has shown they can detect and use this information to navigate across thousands of kilometers of open ocean with remarkable precision, returning to within meters of a specific beach they left decades earlier. The natal homing behavior is one of the most studied puzzles in animal navigation. Females return to the exact beach where they hatched to lay their own eggs. They don't return every year. Some migrate every 2 to 5 years. But when they do, the accuracy is extraordinary. How the map is formed during early life, how it is stored, and how it is retrieved after 20 or 30 years at sea are questions researchers are still working through. Sex in sea turtles is determined by incubation temperature rather than genetics. Eggs incubated below roughly 27.7 degrees Celsius produce males. Eggs incubated above 31 degrees Celsius produce females. This is a significant problem as global temperatures rise. Some green turtle populations are now producing overwhelmingly female hatchlings, raising long-term reproductive concerns. Conservation status is endangered. Green turtles have recovered in some areas following protection. Nesting numbers in Florida and Hawaii have trended upward over recent decades. But globally, the species faces ongoing pressure from bycatch in fishing nets, boat strikes,
consumption of eggs and adults in some regions, and the degradation of seagrass habitats on which they depend.
Loggerhead sea turtle, Caretta caretta. The loggerhead is named for one thing, and that thing is immediately obvious: the head. An adult loggerhead's head is disproportionately large, even relative to a substantial body, typically 90 to 110 centimeters long and weighing 70 to 170 kilograms. The jaw muscles that fill that head are what the head exists to support. The loggerhead has one of the most powerful bites of any sea turtle, capable of crushing horseshoe crabs, queen conchs, and whelks with shells that would resist almost anything else in the marine environment. The shell is reddish-brown and heart-shaped, with a yellow-orange underside. It is the largest hard-shelled sea turtle in the world. Loggerheads have one of the widest distributions of any sea turtle: Atlantic, Pacific, Indian Oceans, and the Mediterranean. They favor temperate and subtropical coastal waters, spending time in shallow bays, estuaries, and along continental shelves. Unlike the green turtle, which stays in shallow coastal zones, loggerheads make extensive open ocean crossings. Pacific loggerheads migrate up to 12,000 kilometers between nesting beaches in Japan and foraging grounds off Baja California in Mexico. They feed on hard-shelled invertebrates: horseshoe crabs, whelks, conchs, clams, mussels, sea urchins, sponges. Anything that lives on the seabed and has a shell or exoskeleton. The loggerhead's jaw crushes the shell, extracts the flesh, and the shell fragments pass through its digestive system. What happens next is worth noting. Those shell fragments are excreted back to the sea floor, where other animals use them as a calcium source. More than 100 species of animals, including barnacles, crabs, and algae, also live directly on the loggerhead's shell. The turtle functions as a moving ecosystem. This is why loggerheads are considered a keystone species. Their presence shapes the availability of resources for a wide community of other marine life. Loggerheads are the most abundant sea turtle species in U.S. waters, and they've been studied intensively. One of the more remarkable findings is the transoceanic developmental migration made by hatchlings. After hatching on beaches in Florida or the Mediterranean, young loggerheads enter the open Atlantic and ride the current systems, the North Atlantic Gyre, for up to a decade, drifting thousands of kilometers before returning to coastal waters to complete their development. They essentially surf an ocean for 10 years before settling down. Loggerheads reach sexual maturity at 35 years. They nest every 2 to 3 years. A female can live to 70 or 80 years, and possibly longer. Conservation status is vulnerable. Some subpopulations are endangered or critically endangered. The largest nesting population in the world is in Florida. Bycatch in longline fishing is the primary mortality driver globally, along with beach development that reduces nesting habitat and artificial lighting that disorients hatchlings moving toward the ocean. Hawksbill sea turtle, Eretmocheles imbricata. The hawksbill is, by almost any measure, the most visually striking of the 7 sea turtles. Adults are small to medium-sized, typically 60 to 90 centimeters in shell length, weighing 45 to 70 kilograms. The defining feature is the head, long, narrow, and tapering to a sharp, hooked point that resembles a bird of prey's beak. That beak is the tool that makes the hawksbill the only sea turtle specialized to feed deep inside coral reefs. The shell is the other unmistakable feature. It is made of overlapping scutes, each one amber, translucent gold-brown with streaks of dark and pale coloring, arranged like roof tiles. This is tortoiseshell. The pattern and translucency that has made it the target of exploitation since ancient Egypt. Japan alone imported an estimated 2 million hawksbills between 1950 and 1992, before the international ban on the trade was enforced. They stay in tropical and subtropical waters of the Atlantic, Pacific, and Indian Oceans. But within those ranges, The hawksbill is defined by its habitat in a way that other sea turtles are not. It lives on coral reefs. Not near them, not passing through them, on them. The ledges and caves of coral reefs are where hawksbills shelter, feed, and spend the majority of their adult lives. As the reef goes, so goes the hawksbill. Diet are sponges, primarily reef sponges. Sponges are chemically toxic to almost every other animal in the ocean. They contain microscopic glass-like needles called spicules that would destroy the digestive systems of most creatures. The hawksbill is immune. The narrow beak reaches into crevices and gaps in the reef structure that other animals cannot access. The hawksbill extracts sponges, digests them safely, and in doing so, provides a service to the entire reef community. Sponges, if left unchecked, overgrow corals and suffocate them. A single hawksbill can consume over 450 kilograms of sponges per year. Without hawksbills, coral reefs shift towards sponge dominance, reducing the structural diversity that supports hundreds of other species. The hawksbill is the only marine consumer whose diet consists predominantly of sponges. There is nothing else in the ocean that plays this role at this scale. Hawksbills are among the most wide-ranging sea turtles in terms of nesting location. They nest in small numbers on scattered beaches across 60 countries, rather than concentrating at large sites. This dispersal pattern makes conservation more complex. There's no single beach to protect. Hatchlings spend their early years drifting in the open ocean in floating mats of sargassum seaweed before recruiting to reef habitats. The transition from open ocean drifter to reef specialist happens over several years as the young turtle locates and settles on a home reef. Hawksbills are among the smallest sea turtles, but among the most navigated. Some populations migrate over 1,000 kilometers between nesting beaches and reef foraging grounds. Unlike many sea turtles, they tend to nest on small, vegetated beaches near reef systems, rather than wide-open sandy shores. Conservation status is critically endangered. Global nesting numbers have declined by more than 80% over the last century. The IUCN assessment confirmed this population-level collapse. The illegal tortoiseshell trade continues despite the ban. Coral reef degradation from bleaching, ocean acidification, and runoff removes both the hawksbill's food source and its shelter simultaneously. The eastern Pacific hawksbill population is considered one of the most endangered sea turtle populations anywhere in the world. Olive ridley sea turtle, Lepidochelys olivacea. The olive ridley is the most abundant sea turtle on Earth and the smallest of the 5 widely distributed species. Adults reach 60 to 70 centimeters in shell length and weigh between 30 and 50 kilograms. The shell is heart-shaped and notably pale, olive gray to olive green, which is exactly how it got its name. The head is small and rounded. It looks, honestly, like a scaled-down, tidied-up version of a Kemp's ridley. And that's because the 2 species are the only members of their genus, Lepidochelys, making them the most closely related pair on this list. They live in the tropical and subtropical waters of the Pacific, Indian, and Atlantic Oceans. Of all 7 species, the olive ridley has the broadest presence across warm ocean waters globally, found from West Africa to South Asia to Central America to Japan. The Pacific population was once estimated at 10 million individuals. Today, the majority of surviving mass nesting populations are concentrated on a handful of beaches in India, Costa Rica, and Mexico.
They're omnivorous. Jellyfish, crabs, shrimp, fish, sea urchins, algae.
The olive ridley forages in surface and midwater zones rather than specializing in bottom-dwelling prey the way the loggerhead does. The diet is broad and opportunistic. One of several reasons this species has maintained the largest population of any sea turtle despite significant pressure. The arrabata. This is one of the most remarkable behaviors in the natural world, and the olive ridley is the primary performer. Arriving. That's what the Spanish word means. And the event it describes is this: tens of thousands, sometimes hundreds of thousands, of female olive ridleys emerge from the ocean simultaneously over a period of 3 to 7 days to nest on the same stretch of beach. A single beach becomes, for the duration of an arrabata, the most densely occupied piece of land any turtle will ever share with its species. The triggers for an arrabata are still not fully understood. Moon phase, wind direction, ocean current temperature, and chemical signals have all been proposed. What is clear is that the synchronization is not accidental. It appears to be a predator saturation strategy. So many turtles nesting at once that no predator population could meaningfully reduce the proportion of eggs that survive. The 2024-25 season at India's Gahirmatha and Rushikulia beaches combined for 1.51 million nesting olive ridleys, a number that broke all previous records. Olive ridleys also nest solitarily at beaches where the critical mass for an arrabata is never reached. Some individual females nest alone throughout their lives. Conservation status is vulnerable. Despite being the most abundant sea turtle globally, the olive ridley has declined by 30 to 36% in overall population over the last century, with some regional populations down catastrophically. Suriname's arrived nesting population has dropped over 90% since 1967. The Pacific coast of Mexico population is listed as endangered. Bycatch in trawl nets and gill nets is the primary mortality driver. Egg poaching from unprotected beaches removes millions of eggs per year across their range. Kemp's ridley sea turtle, Lepidochelys kempi. The Kemp's ridley is the smallest sea turtle in the world. Adults reach about 60 to 70 centimeters in shell length and weigh 35 to 45 kilograms. The shell is circular rather than heart-shaped, rounder and broader relative to length than any other sea turtle. The coloring is pale gray-green on top with a pale yellow underside. The species is named after Richard Kemp, a fisherman from Key West, Florida, who submitted a specimen for identification in 1906, though what exactly he thought it was has never been entirely clear. The Kemp's ridley has the most restricted range of any sea turtle other than the flatback. It nests almost exclusively on one stretch of beach, Rancho Nuevo in Tamaulipas, Mexico, on the Gulf Coast, with a small number of nests also recorded on Padre Island in Texas. Juveniles range more widely into the Atlantic, as far north as Nova Scotia, and cold stunning events in Massachusetts have resulted in hundreds of Kemp's ridleys washing ashore annually in recent years, 684 in 2024 alone. These cold stun events are not normal behavior. They are young turtles being caught off guard by rapidly dropping water temperatures. They eat crabs, primarily swimming crabs, but also shrimp, fish, jellyfish, sea urchins, and mollusks. They forage in shallow coastal waters and estuaries closer to shore than most sea turtles. Like the olive ridley, Kemp's ridleys nest in arrabatas, but the scale is far smaller and restricted almost entirely to that one beach in Mexico. The history of that beach is one of the most dramatic conservation stories in the marine world. In 1947, a Mexican fisherman filmed an arrabata at Rancho Nuevo with an estimated 42,000 females nesting in a single day. The footage, known as the Herrera film, provided a baseline for the species that became devastating to look at in retrospect. Because by the 1980s, the entire global nesting population had collapsed to fewer than 250 nests per year.
The recovery effort that followed was unlike anything attempted for a sea turtle before. Eggs were translocated from Mexican beaches to Padre Island in Texas to establish a secondary nesting population. Hatchlings were head-started, raised in captivity to a larger size before release to bypass the period when they're most vulnerable to predation. Mexico's nesting beaches were placed under armed guard. Shrimping vessels in the Gulf were required to install turtle exclusion devices, funnel-shaped openings in trawl nets that allow sea turtles to escape while retaining shrimp.
Today, the Kemp's ridley is still critically endangered, but nesting numbers have risen substantially from that 1980s low. The recovery is real. It is incomplete, and it has required decades of sustained international effort to get this far. Conservation status is critically endangered, one of the two most endangered sea turtle species. The narrow range, essentially a single beach, means a single catastrophic event, hurricane, oil spill, disease, could devastate the nesting population. The Deepwater Horizon oil spill in 2010 directly affected Kemp's ridley habitat and coincided with a sharp decline in nest counts in the years that followed. Flatback sea turtle, Natator depressus. The flatback is the most obscure of the 7 sea turtles, and in many ways, the most Australian. Adults reach 80 to 95 centimeters in shell length and weigh 70 to 90 kilograms. The feature that names it is immediately visible. The shell is flat. Where other sea turtles have domed carapaces, the flatback's is nearly level, almost like a plate rather than a bowl. The outer edges curve upward slightly. The shell is covered in smooth, thin skin. The coloring is olive gray on top, pale yellow underneath. Habitat is Australia only. The flatback is the only sea turtle species endemic to a single country. It nests exclusively on the northern coast of Australia, from Queensland in the east to Western Australia in the west, and its entire life cycle plays out on the continental shelf surrounding that continent. Feeding grounds extend into the waters of Papua New Guinea and southern Indonesia, but the flatback never ventures into open ocean. This is the other defining biological fact about the flatback. It is the only sea turtle that does not have an oceanic phase. Every other species sends its hatchlings into the deep open ocean, where they drift for months or years before returning to coastal habitat. Flatback hatchlings go into the water and stay in shallow coastal waters for their entire lives. They do not cross ocean basins. They do not ride gyres. They live and die within a few hundred kilometers of where they hatched. The flatback is an omnivore. Sea cucumbers, soft corals, jellyfish, shrimp, crabs, mollusks, and seaweed. It forages in shallow, soft-bottomed coastal habitat, away from coral reefs, in the kind of murky, sandy-bottomed water other sea turtles tend to avoid. The flatback lays fewer eggs than any other sea turtle species, an average of 50 per clutch, compared to 80 to 150 for most others. But those eggs are significantly larger, and the hatchlings that emerge from them are proportionally bigger than hatchlings of any other species. A larger hatchling is harder to eat. In the absence of an oceanic drift phase, which in other species provides some separation from coastal predators, the flatback has apparently traded clutch size for individual size, betting each egg rather than producing the numbers. The flatback also nests during the day on occasion and is preyed upon during nesting by saltwater crocodiles, the world's largest living reptile. Adult females have been attacked and killed by crocodiles while attempting to come ashore. There is no other sea turtle species with a documented predator at that level. Of all 7 species, the flatback is the least studied. The remoteness of much of its nesting habitat in northern Australia, combined with its entirely coastal existence and its restriction to one country, means the global research attention given to other sea turtles has largely bypassed it. Conservation status is data deficient, IUCN. There is simply not enough population data to make a formal assessment. The Australian government, working from more localized data, lists the flatback as vulnerable. Known threats include ghost net entanglement, abandoned fishing nets drifting through the Arafura Sea kill hundreds annually, light pollution from coastal industrial development, climate change, and the same bycatch pressures facing other Australian sea turtles. 7 species, 1 lineage, 110 million years. They survived the mass extinction that took the non-avian dinosaurs. They outlasted the ice ages. They navigated through ocean changes that reshaped the planet multiple times. And then, in the span of a few human generations, 5 of the 7 landed on the IUCN threat list. The hawksbill and Kemp's ridley are critically endangered. The green, loggerhead, and leatherback are endangered or vulnerable depending on the population. The olive ridley is vulnerable despite being the most abundant. The flatback we barely know enough about to classify. The causes are not complicated. Bycatch from fishing gear, egg poaching, shell and meat trade, beach development, plastic. Warming temperatures changing the sex ratio of hatchlings before they're even born. And yet, the Kemp's ridley nearly went extinct in the 1980s and is still here. Green turtle nests in Florida are trending upward. The 2024 olive ridley season in India broke all records. Conservation works when it's consistent, funded, and taken seriously. That's the full list. Subscribe if you want the next species covered. There are a lot of animals left on this list. Drop your request in the comments below.